Hello and welcome to the Heartland Institute's Daily Podcast. I'm Sterling Burnett, Heartland Senior Fellow and Managing Editor of Environment and Climate News. I'm pleased to have as a guest today Howard Brady, PhD, an award-winning geologist and climate researcher from down under in Australia. He's conducted Antarctic climate research in peer-reviewed journals, and he's here to discuss today the second edition of his book, Mirrors and Mazes, A Guide Through the Climate Change Debate. Howard, thanks for being with us.
A real pleasure, Sterling, and I owe so much of my academic life to Americans. It's great to be talking into your country.
Yeah, I see you got your master's degree from, or your undergraduate degree from university in the U.S. I saw that in your bio.
Yeah, not far from Arlington at DeKalb, actually. I know that world pretty well.
Yeah, and they give you an award.
Yeah, in 2001, DeKalb gave me their Alumnus Scientist of the Year award for my contributions to Antarctic research, which I thought was really great. And my wife and I were able to travel across to the States to Atgeld Hall and receive that prize from the Dean. And at the same time, some world-famous scientists actually came to that ceremony to also congratulate me, which was a great privilege.
Very nice. Well, Howard, for our listeners who may not be familiar with you, please tell us a little bit about your background, your climate research, how you got into this.
Well, I'm a very different animal from the normal scientist, Sterling. I started off, I was a Catholic priest scientist, belonging to a French order that was very academic. So I was in education, and then they actually encouraged me to continue my science. So I ended up in a very strange situation where I was Lieutenant Commander Brady to the US Navy in Antarctica, as a chaplain to the Navy at South Pole and McMurdo, and they used me also as a geologist at the same time. And they were so happy with me, Professor Trevors from Nebraska Uni, they invited me to come and study in the United States, and that led to my master's degree in Antarctic science, my PhD in Antarctic science. So I've got so much to thank Americans for the encouragement they've given me. After a decade in Antarctic research, I left academia. I got married. I started to work in the oil industry, investment climate. But in 2005, I was invited back to academia, and I stayed there working on sea level problems until eventually I was dismissed from an Australian university because of my attitudes to sea level and climate science. I regarded a lot of the climate science at the moment as absolute rubbish. So that's briefly where I'm coming from.
They actually let you go because you were a climate skeptic?
They sacked me. Virtually, they didn't renew my position because our CSIRO, which is a big research organisation, was stressing the fact that sea level was accelerating. And I did a lot of work on sea level along the south coast of New South Wales using comparative photogrammetry, looking at the coast in 1945, 2008, and I even got back further with a lot of the surveying that was done. There had been only a linear change in sea level. It had risen steadily, but also it was so far out from the satellite data, I realised there was two sets of data. There was the satellite data that was exaggerated, and there was tide gauge data from all over the world that said that sea level was rising, but not in an accelerating way. It was going up steadily. So, the university didn't like that because I went on the ABC radio. I also went on ABC Radio Pacific to Tuvalu and all those places and told those islands that they wouldn't be climate refugees in a hurry. That did not please the university.
Wow. Well, Howard, now, there are varieties or degrees of skepticism regarding the theory that humans are responsible for climate change, and whether its impacts on human well-being and ecosystem health will be negative. Some don't believe humans are playing any role in the present climate conditions at all. Others think they have a modest impact, and still others think humans are affecting climate, but not likely to have a dangerous impact, even possibly a beneficial one. Where do you fall on this spectrum and why?
I really don't think that the increased carbon dioxide that's gone into the atmosphere over the last 150 years has had a significant impact on world climate at all. But with regard to human beings, the cities have also created their own climate because of the heat island effects. So if you do graphs of climate over cities, you will see there's warmer nights, so man has affected the climate around his big cities. But if you take the data from the countryside, you will see there that there's no relation with CO2. We've had 70 years in the last 150 years where temperature's gone up and CO2's gone up. But we've had another 70-odd years where CO2's gone up, but temperature's gone sideways or even down. And so between 1945 and 75, the CIA was warning the American president of an impending ice age, even though you had all this increased CO2 going up due to the expansion of coal mines after the Second World War. So I don't think there's a very great relationship between CO2 and climate. And as an historical geologist, you go back, there's ice ages with CO2 10 times today, and yet there's still an ice age. So to have a simple relationship between CO2 and temperature is crazy. The whole system is a much more complex non-linear system. Simply going on CO2 and temperature gives you all the wrong answers. So I don't think anything we're doing with CO2 may help our atmosphere here and there because coal has a lot of other nasties, for example, but affecting climate, no, we're not doing anything. We're out of control. It's a bigger system. We're not going to change the climate.
Well, Howard, what was the impetus for your book, Mirrors and Mazes?
Well, it's a very, very interesting story. I never expected to write a book, but Bob Carter, whom I think a lot of Americans would know, professor at James Cook University, he's written a book on climate, the Counter Consensus. I know he's spoken for the Heartland Institute. He was an advisor to your institute, spoken all around the world. Bob came to my house and stayed for a few days looking at the research I'd done on the south coast of New South Wales. And the problem there is that, and a lot of people, climate doesn't worry them, but if you live on the coast and suddenly a local government authority says sea level is going to go up 2 metres and maybe your house is going to have to be shifted or you're not going to be able to build anymore and you see the value of your property slump from, say, $1 million to half that, you're going to be worried about the climate debate. And so I was on a beach, in a beach area, where suddenly the council had gone bananas, worried about sea level rise and started to draw lines on people's properties. It didn't worry me because I was on a cliff, but it worried a lot of people. And then I saw there was a need for a book to explain to ordinary people what's actually happening in the climate debate. And also people needed a book where they could give to their local members and say, look, read this chapter on, say, storms or on the sun or something and come back and talk to us. Don't make all these stupid statements. So out of that meeting with Professor Carter and what was happening in this local little village with regard to sea level, I decided what was needed was a short book. It had to be written in a very popular style, but it had to have good data. And above all, it shouldn't be polemic. It shouldn't be attacking individuals. That's a distraction. It should just give ordinary people what are the problems in this debate, and this is how you can understand it. And then while I wrote the book, it was very funny. I decided that each chapter would be read by a plumber, a real estate agent, 2 professors, and an accountant. And so I got all these weird comments coming from guys. We didn't like that chapter. We didn't understand that. And that's how the book developed. So it was a lot of fun, but it took a few years to write. So that's the story of the book, Sterling. But I think it's had a very unusual history.
As you wrote it, you had it reviewed by, let's just call them the common man, people who aren't academics, who aren't steeped in the literature, and by scientists, so you could give sort of a thorough and accurate description, but at the same time something that the average person can understand.
Yeah, that's right. And one of the guys that helped me was my oldest son, who's an Aboriginal archaeologist and also a fluvial geologist. And he'd look at a chapter and say, Dad, that's too hard. You've got to give the reader a rest, some stories. So I had all this input, and without it, I really couldn't have written the book.
Gotcha. Well, that's really a great way to work, and something I think that academics don't get enough understanding of. That's something we strive for at Heartland, is everything we publish should be accessible for your average Wall Street Journal reader or even sort of high school student. If they can't understand it, we've missed our target audience.
Sorry. Yeah, Bob Carter actually sent me a message. Howard, this book is a great read. Loved reading it, and that's what I wanted to achieve.
Howard, let's talk about sea levels. I think I know what your answer is going to be based on what you've said, but are sea levels rising dangerously globally, and can sea level rise be tied to human greenhouse gas emissions?
I was telling the answer to both those questions is no. Sea level has been very close to my research because I came from a little coastal village where my wife and I had a house. The local council was putting lines on people's properties saying that they were going to be inundated by sea level rise up to 2 meters this century. The locals were saying it looked as more sand in front of our houses than 40 years ago. So as a field geologist, I went back and I looked at aerial photographs from 1948 to the present, and there'd been no retreat at all. And as a matter of fact, some of these beaches had been advancing seaward because the grass and the seaweed has been in the forage dunes that collect so much sand. So then I went back and looked at the data, and at Fort Denison, which is one of the best tide gauges in the world, it showed no sea level rise above 8 centimetres a century in the last 150 years. And yet the satellite data, and the satellite data only started in the 90s, was saying that the sea level around Fort Denison was going up at 30 centimetres a century. So this was a problem. There's two sets of data, and at Liverpool in England, they've got all the data from tide gauges around the world. Sea level's going up steadily, no acceleration, and you've got this satellite giving the high readings. So I contacted the satellite design engineers in Pasadena, and they told me there's a problem with the Jason satellite series. It can't give you absolute accuracy to what's really needed. And they've actually designed a new system called GRASP to get around this problem, but they can't get the money from the US Congress. So that all of this satellite data, which is giving high levels, four times more sea level rise at Fort Denison than the tide gauge, all that satellite data is suspect. It may be giving us relative movements between point A, B, and C, but it's not the absolute data. And yet a lot of people are using that. And a lot of people are actually correcting the tide gauge data up to the satellite data. Some engineers in Australia have taken the data where my wife and I have got a house, and they have adjusted it up from 8 centimetres a century to 30. So the sea level debate's a mess. And if you actually go to the IPCC, you will see all those early meetings, 1990, 94, 97, they all looked at tide gauges around the world, and all those technical committees said there is no sign of any acceleration of sea level. It was only when the satellite data came in that they said, wow, we can use this to show acceleration, and we can, and that goes in with our models. But in point of fact, sea level is not accelerating, and therefore that means that the climate models themselves have a problem. There's something internally wrong with those models if they're predicting sea level is accelerating when it isn't. And finally, Professor Houston at the US Army Corps of Engineers, for example, and others, have looked at the data in Australia and their own data, and the data seem to suggest that sea level is still rising, but it may have slowed down a little bit. So much for these stories of acceleration. So I don't think that CO2 has been doing anything with regard to sea level. I don't think there's any panic. I do think that when the storm surges, which are very critical, that's due to hurricanes and cyclones, you'll get 2 to 4 metre rise in sea level due to low pressure, but that's got nothing to do with climate change. And when some governor in California talks about a storm surge as being climate change, he doesn't know what he's talking about.
So just to be clear, I mean, this is a second instance. We already know, I've explored this many times, that the temperatures projected by climate models are way off. The average of all the models is well above what the actual measured temperatures are. It's outside, in fact, they're so far above it, it's outside the margin of error for the models. And it's crazy. And now we find out that when it comes to sea levels, it's another instance of, are you going to believe your lying eyes and the data, or are you going to believe what my model tells you is happening? So you've got a house on the beach, and you can see that the tide is not rising. In fact, it's receding. I now have more land outside my door than before, but you're telling me I'm underwater.
Yeah. Well, I think the big problem happened in 1979. The US Academy of Science under Chani met for a week, and they tried to come up with a climate sensitivity index. And at the time, they only had two computer models. They had a Japanese guy, Manabe, at Princeton. They had James Hansen, and they both said the sensitivity of the system to doubling of CO2 was between 2 and 4 degrees. But in that index, water vapor and clouds tripled the effect of CO2. So they came up with this average index of 3 degrees. So the trouble wasn't so much CO2, but the assumption that water vapor and clouds tripled the effect of CO2. Now, since 79, virtually all the models have been running on an index around that 3 degrees Celsius for doubling CO2, and they're getting all the wrong answers.
It's the feedback mechanisms. It's not the physics of CO2. It's the assumptions about what feedback mechanisms will do.
That's right. And if you take people like Linz and Chow, they think the sensitivity could be 0.5 degree, Mizolsky around the same, others around 1 degree, but much, much less than the 3 degrees. So the climate models since 79 have been on steroids, and they're still on steroids. And it's about time we did something about it.
Well, let's look at something different. In your book, you've got a whole chapter on the sun's role in climate change, and you discuss the Intergovernmental Panel on Climate Change. So what are your thoughts on the sun's role, and what has the Intergovernmental Panel on Climate Change gotten right concerning climate change, and where has it gone off the rails?
Well, that's two separate questions. The first one on the sun, the assumption has been that the total solar irradiance doesn't change very much, and therefore the sun's doing nothing. Now, if you measure total solar irradiance over a short period of time, that is absolutely correct. It's not doing very much. But in the book, I think in chapter 11, I describe the sun like a trickster at Las Vegas, saying, I can do things in front of your eyes that you won't believe, and you won't even know how I'm doing it. Because the sun can influence climate now, we know, in so many different other complex ways. Now, one is the magnetic field of the sun, it flips every 11 years. And not only that, as it changes in intensity, it alters the amount of cosmic rays coming into the Earth, and that seems to be affecting cloud formation. So if the sun can act as a trigger affecting cloud formation, it's critical in changing climate. Another thing is that the sun is exploding and then gravity is bringing it together. So it's a pulsating body like a human heart. Now, the Russians at the Pulkovo Observatory have done a lot of work on this, and they've got a camera system on the International Space Station measuring changes in the radius of the sun. Now, those changes can be as much as 100 to 300 K. It may not seem much, but a 300-kilometre change in radius of the sun changes its surface area by 1.5 billion square kilometres. So the amount of heat coming from a body depends on its surface. So the sun's changing there. Apart from that, the big planets are causing the sun to wobble. So it's changing its distance from the Earth by about 2 solar radii. So there's a lot of very little tricky ways, and I won't get into ozone and other things, that the sun does affect climate. So chapter 11 was a hard chapter to write. But when we go back and we look at geological history, if we go back to the Little Ice Age, we know that the cosmic radiation was a lot then. We know that sunspots were low, therefore the magnetic field of the sun was low. There was more cosmic radiation coming in because it caused an isotope called beryllium-10 to form. We know it was a cold period. If we go back in sediments, we can find other periods of high beryllium-10 isotopes, and we can link them with other cold pulses of the sun. So the sun is involved in climate. It is not like some little steady light globe up there not changing much at all. It's very much involved. Our whole life depends on it, and it, to a large extent, does control our climate. Now, the second question you asked was about the IPCC. Well, boy, they've made so many statements about so many things and with so many committees. Some of the things they've said are good, Some of the technical communities are very good, technical reports have very good information in them. Other things are just sheer exaggeration. So it's very hard to go through all of them. One thing it exaggerates is acidification of the ocean. The idea is when CO2 goes up, it does slightly change the pH of the ocean. It does. But the pH of the ocean is still alkaline. By saying it's more acidic, it's just a little bit less alkaline. That doesn't make any difference. If it was acidic, it would be dissolving corals and everything else. And we know in that whole history of the Earth we've got from geological history, it's never been acid at all. It's always been alkaline. And we know that when CO2 levels were 10 times today, the ocean was still alkaline. So exaggerating that is stupid. Also in the IPCC, they've been taking a lot of these extreme weather events and saying they're caused by, CO2, etc. And they've been panicking about a lot of other things and linking them with climate change. For example, diseases.
Let me interject for just a moment.
Please. It's so many complex things.
Because I want to stress two things that you said concerning the alkalinity of the ocean. So even when, because I want our listeners to get this, even when CO2, carbon dioxide, was 10 times higher than today, much higher than they're anticipating it to be due to human causes. They're talking about a doubling, but you're talking about 10 times. It was still alkaline, right?
Absolutely.
Now you're talking about you moved on to what? What was extreme weather. This is something I don't get. People are calling things extreme weather. Look, when I was a professor, when I taught, you had an average in the classroom. You can talk about the classroom average. And for most most classes, it's C. It's in the 70s. But so someone gets an F and someone gets an A plus, right? They get 100. One guy gets 100 and another guy gets 20. Are those extreme? Well, okay, you can call those the extremes, but it's all relative to an average. You get an average by the extremes. Most people don't get 75s, which would be the average. Most people get 80, some get 60, a couple get A's, a couple get F's, and that drags it down to the average. Everything around the average is not an extreme. It's just variability. And it seems to me that's what's going on with weather. We're not seeing extremes. We're seeing variability, which has been natural. It happens throughout history.
Sterling, what I did in Chapter 5 of the book, I took things like cyclones hitting Australia. They've actually been slightly declining over the last 30 years. And as a matter of fact, the Science Award in Australia was given to a Professor Farquhar in 2015 for showing that winds have been slightly declining over the last 40 years. Another graph is what is called a tropical wind intensity index, which is the highest winds in the tropics every 6 hours. That's been graphed for the last 40 years. It's just got ups and downs. There's no rise. If you put a graph of CO2 against it, no correlation. And then you get hearing these stupid comments from Florida each time there's one of your hurricanes saying this is climate change. Well, if you look at the graphs of all those storms hitting Florida, there's been no statistical change. As a matter of fact, the ones you've had this year, there was before them, it was the biggest break since the Civil War. And then if you go back and look at the populations in Florida, 1900, I think around 500,000 people. 1960, 5 million. Today, 25 million. So every time there's a cyclone, or a hurricane, whatever you want to call it, there's stacks more damage. That's got nothing to do with CO2. There's a lot of more people around.
But because more people are experiencing it now, and more people are seeing it on the news because we have the 24-hour news cycle and everyone's got a TV or a smartphone, the perception is it's getting worse all the time, but the data doesn't support it.
That is absolutely correct. And I've got 4 graphs in there showing that. And even tornadoes. The worst tornado year in your country you would know would be 1974, when there was a huge pile of cold air that hit the Rockies from the Canadian border down to Mexico. And as it rolled over, there was tornadoes all the way from Chicago down to the Mexican border. There was hundreds of tornadoes. The worst year ever. And that's one of those extreme things that you mentioned. But when you graph tornadoes, again, there is no statistical relationship with carbon dioxide at all.
Well, in fact, if the worst year was 74, and I'm not disputing you on that, I just haven't seen the data. But if that's, in fact, the truth, what we know is in 74 is when they were writing about the coming ice age.
Yeah, that is correct. Yeah, it was April 1974. I can tell you that.
Yeah. So, Howard, what are your thoughts on the use of fossil fuels and the relative merits and drawbacks of renewable energy sources? Do you believe government needs to force an abrupt shift from fossil fuels to renewables?
Right. First of all, I'm not an electrical engineer, so a lot of the connections between renewable energy and standard grids is above me because it's different. But in general, when I worked in the oil industry for a while, and when I started, we were using 50 million barrels of oil a day. Now it's about 90. Now it makes sense that over time we're not so reliant on oil or gas as something. But the assumption is that's to do with economics and the human use of materials. It's got nothing to do with climate. The trouble is that as soon as the government starts to subsidise these, thinking that it can affect climate, all it's doing is creating a rise in the price of electricity, affecting the industrialisation of some countries, and then China and those countries that are given a free ride are benefiting. The whole renewable thing is a mess. We have people investing in it simply because they're getting double pricing. They're getting pricing from the customer, they're getting pricing from the government. So the subsidisation on a large scale is bankrupting some countries. It nearly bankrupted Spain. It's not going to achieve anything. A little bit of subsidy is good because we need to develop other technologies. No debating about that. But at the end of the day, I really doubt that wind will be the answer. Nuclear or fusion or something that's not quite as dangerous as the modern fission could be. Man's inventiveness is going to solve that problem. And the government should spur some advanced research into renewable and other technologies. But the way we're going about it, thinking we're going to do this urgently and spending trillions on it to solve climate change, that's not achieving anything.
It's retarding growth in developing countries, and it's achieving higher prices which harm the poor in developed countries. It is achieving that.
Absolutely. And of course, we've got this incredible situation. The highest electricity prices in the world are in South Australia. We've had a left-wing government down there. They are so determined to show we don't use coal anymore. They've been dynamiting coal stations so they can never be used by a future government that may not be as left as them. And they've got the electricity price up to 45 cents a kilowatt hour or something, which is about 3 times your price. And businesses are leaving.
No. I'm in Texas. It's more than 4 times my price.
Yes. Well, that's what's happening in South Australia. And it's an unbelievable situation. And then when the wind didn't blow about a year ago, there was suddenly a huge power failure all through South Australia. And you wouldn't believe it. Elon Musk said, I'm going to save you guys and I'm going to give you a battery. So they then got him to put a $100 million battery in. And that will supply enough electricity in South Australia for about 2 minutes. And that will help you to relocate to another grid if there's a problem in the interchange. But it doesn't solve any sort of supply problem. So South Australia, we're leading the world, I'm afraid. And Germany, I think, is following us.
Well, Howard, big picture. If you could make just one point from your book, Mirrors and Mazes, what's the most important single point you'd have our listeners take away from our discussion today? Well,
you've got probably the most famous oceanographer last century was Professor Wallace Brooker at the Lamont Doherty Observatory in New York, where I was actually privileged to study for a brief period. And he said, at the end of my career, we have greatly underestimated the complexity of the climate system. And the whole tenor of my book is to say, look, it's not just CO2 and temperature. That's all wrong. We put the climate models on steroids. We've got to relax. We've got to adjust to climate change. We've been through much warmer periods in the past, like 8,000 years ago when the rainforests in Australia were 300 kilometres south of where they are now. Let's just enjoy the warming while we've got. Don't worry about it. Let's get on with our lives.
Profound statement. I wish more people would take that to heart. Dr. Brady, we've been pleased you could be with us today to discuss your book, Mirrors and Mazes, and I want to thank you on behalf of myself and our listeners.
Thank you very, very much indeed, Sterling. And I've seen some of your work on renewables, and I really enjoyed talking with you. Thank you.
I appreciate you saying so. Listeners, thanks for checking in on us today. Please check Heartland's website as we follow the work on climate change of Dr. Howard Brady, and go frequently to our PolicyBot site, your one-stop shop for free market solutions to public policy problems. In addition, if you're not already receiving these podcasts daily on your favorite device, go to iTunes and subscribe. And when you have the time, please rate our podcast on iTunes so you can help us expand the reach of free market ideas. Thanks. Take care. Bye.